Okay. So, intro to systems of equations. Jules opened a checking account with $500 and plans to spend $50 each week. Astrid opened a checking account with $50 and plans to save $25 each week. An equation showing the relationship between X, the number of weeks, and Y, the account balance, which is how much they have in their account, is shown for each account. Graph each equation. Use the graph to answer A through C. Okay, so we have a graph. We're measuring weeks and the balance in the account. We're going to do this carefully, but if you do have different colored pens, it's probably going to work out better that way. Okay? So I'm going to pick maybe green and red. Okay? And let's look at Jules. So let's graph Jules here in red. All right? I'm going to really zoom in so we can all see. So we're going to go ahead and graph this. There's going to be a lot of graphing in the next couple of days, okay, guys? So let's see. How much does Jules start off with? $500. So that's here. And every week she's going to spend $50. So I'll just go down 50 over 1, down 50 over 1. And I'm going to just graph this line as carefully as I can. The thing with this is you really want to get as many points as you can so that your line is as accurate as you can. Okay. Okay, so boom. There's a line that represents how much is in Jules' account. And let's go ahead and do Astrid. I'm going to do Astrid in a different color. Okay. And the thing with Astrid is she's saving $25 each week, right? So it's going to take her 2 weeks to do 50, right? So her points would be something like this. Up 1 across 2. Up 1 across 2. Up 1 across 2. Okay. So I'm going to graph hers like this. She saves $50 in 2 weeks, so it's up 1 across 2. And there's a line for her. Okay. So we got the graphs. And so the question is, where do the graphs intersect? At 6 weeks. Six weeks, and how much money are we talking about? $200. Okay, so here's the most important part. Based on the situation, what does that intersection point represent? When they both have the same amount of money. And we know the amount of money they're both going to have at that point. $200. So let's say when Jules and Astrid have the same amount. That looks like same amount. It's same amount, which is $200. How can we do this part C? Prove that their points of intersection is a solution to each equation by substituting the values into the equation. Okay, so we're talking about 6 comma 200. Okay, so let's do this. Both equations are in what we call slope-intercept or function form. Let's replace x in each equation with 6. Okay, so let's start with Jules here. Y equals negative 50 times 6 plus 500 and let's see, that's going to be negative 300 plus 500, which is 200, which is what we wanted. Okay, let's do the same thing for Astrid. Let's take her equation and we're going to replace x with 6. Y equals 25 times 6 plus 50. So this is going to be 25 times 6 is what, 150? Plus the 50 also makes 200, which is what we should have gotten there. Okay. All right. So basically, we just looked at a system of equations. To be specific, this is called a system of linear equations. So whenever you have 2 or more linear equations that use the same variables, so write the word variables there. That's what a system is. Whenever you have 2 or more, typically it's going to be 2, but it could be 3, it could be 4. When you get into it, if you go to college and take linear algebra classes, the name of the class is specifically linear algebra, it's not uncommon that you have an infinite number of linear equations with an infinite number of variables. And it seems weird, and how does that even work? It's possible, it works. And some of you may learn that, especially if you're planning on going into a math or computer science field. Okay, so basically whenever you have 2 or more linear equations with the same variables. So a solution to a system of equations, the solution of a system is the ordered pair I'm going to write ordered there and pair that makes the equation in the system true. So basically, it is what we ended up with right here. That point of intersection. That was the solution. And we verified it by plugging in and checking to make sure it worked. Okay? All right. So we're going to go ahead and move on to the second part. So this is going to be more typical of what we're going to do today. These two next examples. So when a system of linear equations is graphed, we can find the solution of the system by looking at the points of intersection. So we're going to look for the point of intersection. In the example below, graph the system of equations, find the solution to the system, and check your work by substituting into the equation. Okay, so let's do this. So we got two equations, right, for number one, and we're going to graph them. We're going to do this by just finding the slope and the y-intercept. Okay? So let's start with this first equation. What's my y-intercept point? -2. So at -2, I put a point. And then my slope is -1, right? So that would be -1 over +1 as a slope. So I go down 1 over 1. And here's the thing. When we're doing this without the aid of a computer, it makes sense to do rise over run a bunch of times because you never know which one of these is going to be the intersection point. So I'm just going to do a bunch of them. So let's go ahead and graph all those points. And we really do have to be as accurate as possible. I almost want to do it all the way across. Okay, there we go. There's one line. And let's graph our second line. This one's going to cross at 7. And the slope is 1 over 2. You go up 1 across 2. And then since I can't do anything anymore up 1 across 2, I'm going to go down 1 and to the left 2 a bunch of times. And it looks like it's going to intersect down here somewhere. Aha, I found it. Right there. So there is our intersection point. This is our solution at, what is that? -6, -6, +4. So we're saying that the solution is at -6, +4. Bless you. Let's check it. Okay. So let's plug in -6 and see if we get 4 for each of these equations. Starting with the first one, we should get 4 equals -6. Take away 4. So -6 is going to be, oh, sorry, making a mistake here. This should be 2, not 4. I don't know why I put that. It's -2, not -4. Let me fix that real quick. -2. So 4 equals negative negative 6, which is just 6. Take away 2, which is true. That does make 4. So far, so good. Let's do the other one. The second equation. So we want 4, which is our y value, equals 1/2 times 6 plus 7. Oh, negative 6 plus 7. It's 1/2 times negative 6. And so here, half of negative 6 is negative 3 plus 7. Is that going to be true?
Yes.
Yes. So it works in both. So, I mean, I'm not going to make you check them all the time, but since this is our notes, and I want you to understand that the solution has to work in both equations. That's the key. The solution, whatever the solution is, should work in both equations, okay? All right, let's graph number 2. Y equals negative 5. Ooh, we haven't done one of those in a while. What kind of line do we get when you have y equals negative 5? Yeah, one of those horizontal lines at 5. So let's look for negative 5. And it's going to be just a perfectly horizontal line with a 0 slope. So right at y equals negative 5, we're going to make a perfectly flat line. Okay, there's our first line. And then our second line is going to be at y equals negative 2x minus 3. So we'll look for negative 3. And the slope is negative 2 over 1. So down 2 over 1, boom, right there. Look at that. I see where it intersects right away. We have an intersection point right here at 1, negative 5. Okay? At 1, negative 5. Now, if we were to plug in 1, negative 5 in both of them, then it would work. And so you could see the first one. Replace y with negative 5. There it is, it works. And we can do the second equation. Negative 5 equals negative 2 times my x value, which is 1, minus 3. And that's negative 5 equals negative 2 take away 3. Is that going to give me negative 5?
Yeah.
Sure does. So it works out there. All right. Any questions? Okay. So I would like you to try number 3. Try number 3. Go ahead and graph it. Don't worry about the check. Graph it and see where the two lines cross. And remember, since the slope is 5 or 5 over 1, you're supposed to go up 5 and over to the right 1 But if that doesn't work, what can you do besides up 5 and over to the right 1? Yeah, down 5 and to the left 1. So for time's sake, let's take a look. Hopefully you got something like this. So my first line is crossing at positive 5 on the y-axis. I couldn't go up 5 over 1, so I went down 5 over 1, and I just drew my line. The second line is crossing at negative 3 on the y-axis, and I had to go down 3 over 1. And then I went back over and I went up 3 into the left 1. And lo and behold, that's the common point. So both of them cross at negative 1, 0. That's your solution. So the solution to this system is negative 1, 0. Okay? All right. Let's try number 4 together. This time we got x equals 6. What kind of line is that going to give us? Well, horizontal is when y equals 6. This one's going to be vertical. So go to the x-axis to 6. And right here. And this is going to go straight up and down through there. This is going to be a vertical line. Like so. Through 6. So here's x equals 6. Okay. Let's graph the second line. Y equals 2/3 x plus 3. So let's see, crossing at 3. 1, 2, 3. And then it's 2/3. So up 2 across 3. Make sure I did that right. 1, 2 over 3. Up 2 across 3. What's going to cross right there? Way up in the corner. It looks like. So what's my solution here? 6, comma 7. 6, 7. There we go. Okay. All right. How are we doing on time? Actually, we're doing okay on time. let's try this word problem. So Pedro is 10 miles from Sam's house and is driving at a rate of half a mile per minute to meet Sam. Sam leaves his house driving at a rate of 75 miles per minute to meet Pedro. The system represents the situation shown. Okay, so we got minutes and distance from Sam's house. Let's go ahead and figure this out. Let's start with, this represents Pedro. And we're going to start at 10 miles away. Okay. And it's 1/2, right? So he goes every mile every 2 minutes. 1 mile every 2 minutes. 1 mile every 2 minutes. So he started off 10 miles and he's going 1 mile every 2 minutes, like that. And that's Sam. Let's figure out, oh no, that's Pedro, right? Yeah, that's not Sam, that's Pedro. Sam is the next person. Where does he start off? At 0. He's at home, right? And he's going a little faster. He's going 2/3 of a mile, or 3/4 of a mile, I should say, right? It's 0.75, 3/4. So he goes 3 miles every 4 minutes. So it looks like they meet up here. So let's see what their point of intersection was. 8 and 6. 8 minutes. 6 miles. 8 minutes and 6 miles. So what does the solution mean in the top context of this solution?
Where do you meet up?
Where do they meet up?
They both met 6 miles in.
Yeah. Yes, they meet up. Well, let's see, what do the miles represent? 6 miles.
Oh, they met up 6 miles away from Sam's house.
6 miles away from Sam's house in
8 minutes.
8 minutes. Yeah. All right. We'll just do one more. let's see. List a system of equations to represent it on the graph as well as the solution. Well, the solution is easy. The solution has to be 8 and 50. But we got to come up with some equations for this. Well, fortunately, we know a little math here. Let's start with this first one, this one that's increasing. Y equals, what's the slope here? It's 1 over 2, but let's see what they represent. Going up 1 is actually what? 10. 10 over 2. So 10 over 2 would be 5. So y equals 5x plus 10. Okay. So we got that one. Y equals 5x plus 10. The slope is 10 over 2, which is 5x plus 10. Let's figure out this one, the other line. Where's this one crossing? 90. And what's the slope? Negative 10 over 2, which is negative 5. Plus 90. Okay, so for the last part, summarize today's lesson. I want you to finish this sentence. I learned a system of equations is, well, let's kind of throw out some ideas. What is a system of equations? What do we have there? That's a system of equations right there. How many equations do we have? So it's when you have two or more, well, it could be any type of equations, but when you have two or more equations and you're looking for where they intersect, there you go. That's basically what a system of equations is. When you have two or more equations and you're looking for the solution, which is the intersection point. Okay. And its solution is the intersection point. Boom. Okay, I'm going to pass out glue sticks in a little bit. The assignment's going to be on delta.
How many?
I'm not sure, like 15 or so.